School of Management Studies IGNOU presents an audiobook on the course Mmpc 008 Information Systems for Managers for MBA program. Block 3 System Analysis and Computer Languages Unit 10 System Analysis and Design Part 1.
Introduction. Software is required to automate a process. The process to be automated could be any part of an activity or many activities at the organizational level in terms of an information system. Success of any system depends on the approach of building it. If the development approach is right, the system will work successfully. From the inception of an idea for a software system until it is implemented and delivered, and even after that, the system undergoes gradual development and evolution. The software is said to have a life cycle composed of several phases. Each of these phases results in the development of either a part of the system or something associated with the system, such as a test plan or a user manual. In the traditional life cycle model, each phase has well-defined starting and ending points, with clearly identifiable deliverables to the next phase. Objectives. After reading this unit, you should be able to describe systems development life cycles, identify different phases of systems life cycle, explain the process of system analysis, describe the conceptual basis of system design, and know about implementation and maintenance of software. Application software development and customization. Information system is an arrangement of people, data, processes, information presentation, and information technology that interacts to support and improve day-to-day operations of a business, as well as support the problem-solving and decision-making needs of management and users. Information system is categorized as application software. It can be standalone module, that is, subsystem, or an integrated system to automate processes in the organization. Software is developed using computer languages. This process is also known as coding. Development of software is either done by internal team or it can be developed by any IT service provider as decided by the organization. Before going for the development of the software, all users of the desired software in the organization give the requirements. Based on these requirements, only the software is developed. Nothing more, nothing less is the mantra which is followed for automating the business processes. Similar like constructing a building, the software development undergoes several well-defined steps like requirements gathering, doing analysis for the cost involved, and readiness to adopt the new system, doing analysis for inter- and intra-process relationships, preparing designs, coding and testing of the developed software, installation of the software, and finally putting the software into practice by imparting all necessary and sufficient training to users for making it sustainable. All these steps are linked to one another to build the application software. They have been elaborated in further sections. You have seen the concept of integrated applications with examples like ERP, SCM, CRM, etc. These software are not developed again and again by organizations for business automation. Rather, they are developed by IT companies in such a way that the produced system becomes generic. They can be further changed to suit the requirements of organizations globally. Software tools are available to make such application software. The process of making changes in already developed application software is called customization. It is standard practice available these days. Here, also requirements for users are required to make changes accordingly. Coding is also required to fill gaps under the customization process. Similarly, other steps of software development are also required in adopting and adapting the system, be it CRM, SCM, ERP, or any other third-party developed software. Systems Development Lifecycle. The goal of the information system lifecycle is to keep the project under control and assure that the system produced satisfies the requirement. The system lifecycle is the oldest method for building information systems and is still used today for complex, medium, or large system projects. This methodology assumes that an information system has a life cycle similar to that of any living organism with a beginning, middle, and an end. This is known as the Systems Development Life Cycle, SDLC. The traditional system life cycle divides the project mainly into 4 steps, each of which has distinct deliverables, such as computer programs, standard operating procedures, or design documents. The deliverables are related because each subsequent step builds on the conclusion of previous steps. Some deliverables are oriented toward the technical staff, whereas others are directed towards or produced by users and managers. The latter ensure that users and their management are included in the system development process. The traditional system lifecycle is a tightly controlled approach designed to reduce the likelihood of mistakes or omissions. Despite its compelling logic, it has both advantages and disadvantages. Adherence to fixed deliverables and sign-off improves control but guarantees a lengthy process. Having specific deliverables due at specific times makes the schedule of deliverables. When merely going through the motions of producing deliverables on schedule, participants may be tempted sometimes to turn in work that is complete and to approve documents they do not truly understand. However, the traditional SDLC is the standard against which other approaches are compared. Project managers who want to bypass some of its steps still need a way to deal with the issues they raise. SDLC is a standard methodology for the development of information system. Traditional SDLC was strictly sequential. The software developers had to first complete the previous phase, then start the next phase. But now, concept of repository is introduced in SDLC, and it is known as fast SDLC methodology, where work is done across shared repository. It means that all the inputs and outputs of phases must be stored in the repository. At any time, developers can backtrack to previous phase, and they can also work on 2 phases simultaneously. Repository is thus defined as data store of accumulated system knowledge, that is, system models, detailed specification, and any other documentation that has been accumulated during the system's development. This knowledge is reusable and critical to the production system's ongoing support. The repository is implemented with various automated tools, and it is often centralized as an enterprise business and IT resource. In SDLC, it is also possible to complete some activities in one phase in parallel with some other activities of another phase. Sometimes, life cycle is iterative, that is, phases are repeated and required until a satisfactory and acceptable system is found. Some people consider life cycle to be spiral, in which we constantly cycle through the phases at different levels of detail. The life cycle can also be thought of a circular process in which the end of the useful life of one system leads to the beginning of another project that will develop a new version or replace an existing system altogether. Every custom software producer will have its own specific detailed life cycle or system development methodology. Even if a particular methodology does not look like cycle, you will discover that many of SDLC steps are performed. SDLC techniques and tools are used. This model resembles a staircase with arrows connecting each step to the step before and to the step after it. This representation of the system development life cycle is sometimes referred to as the waterfall model. We use this SDLC as one example of methodology, but more as a way to arrange the steps of system analysis and design. Each phase has specific outputs and deliverables that feed important information to other phases. At the end of each phase, system development project reaches a milestone and as deliverables are produced, parties outside the project team often review them. SDLC consists of mainly 7 phases. These phases are also called as SDLC steps or stages. These phases are 1. Project identification and selection. 2. Project initiation and planning. 3. Analysis. 4. Logical design. 5. Physical design. 6. Implementation. 7. Operation and maintenance. Project identification and selection. The first phase in the SDLC is called project identification and selection. In this phase, the user identifies the need for a new or improved system. This phase tries to answer the questions: why do we need a new system? And what do we want to accomplish? This stage determines whether the organization has a problem and whether that problem can be solved by building a new information system or by modifying an existing one. If a system project is called for, this stage identifies its general objectives, specifies the scope of the project, and develops a project plan that can be shown to management. In large organizations, this identification may be part of a systems planning process. Information requirements of the organization as a whole are examined, and projects to meet these requirements are proactively identified. The organization's information system requirements may result from requests to deal with problem in current systems procedure, from the desire to perform additional tasks, or from the realization that information technology could be used to capitalize on an existing opportunity. These needs can then be prioritized and translated into a plan for the information system department, including a schedule for developing new major systems. In smaller organizations, determination of which system to develop may be affected by user request submitted as the need for new or enhanced system arises as well as from a formal information planning process. In either case, during project identification and selection, an organization determines whether or not resources should be devoted to the development or enhancement of each information system under consideration. The outcome of the project identification and selection process is the determination of which systems development project should be undertaken by the organization, at least in terms of an initial study. Project initiation and planning. The second phase is project initiation and planning. The problems that are identified should be investigated and a decision to implement the information system or not for the organization should be taken. A critical step at this point is determining the scope of the proposed system. The project leader and the initial team of system analysts also produce a specific plan for the proposed project, which the team will follow using the remaining SDLC steps. Now, this baseline project plan customizes the standardized SDLC and specifies the time and resources needed for its execution. The formal definition of a project is based on the likelihood that the organization's information system is able to develop a system that will solve the problem or use the opportunity and determine whether the costs of developing the system outweigh the benefits it could provide, based on cost-benefit analysis. In case of large projects, the IS department may propose for getting the system developed and implemented by a third party. The final presentation with the subsequent project phases is usually made by the project leader and other team members to the organization's management or to a special management committee with experts. Some of them may be from other similar organizations. With all such presentations, finally the decision is taken about the projects the organization will undertake. Analysis. Analysis is the next phase. During this phase, the analysis has several subphases. The first is requirements determination. In this subphase, system analysts work with users to determine the requirements and expectations of users from the proposed system. The system study stage analyzes the problems of existing system in detail, identifies objectives to be attained by a solution to these problems, and describes alternative solutions. The system study stage examines the feasibility of each solution alternative for review management. This stage tries to answer the questions: what do the existing systems do? What are their strengths, weakness, trouble spots, and problems? What user information requirements must be met by the solution? What alternative solution options are feasible? What are their costs and benefits? Whether the project should be executed by external agency. Answering these questions requires extensive information gathering and research, careful study of current system, manual or computerized, that might be replaced or enhanced as part of this project, seeing through documents, reports, and work papers produced by existing systems, observing how these systems work, polling users with questionnaires, and conducting interviews. In this phase, system analysts work like students to learn and find out user requirements. All of the information gathered during the system study are used to determine information system requirements. Next, the requirements are studied and structured in accordance with their interrelationships and eliminate any redundancies. Third, alternative initial design is generated to match the requirements. Then, these alternatives are compared to determine which alternative best meets the requirement in terms of cost and labor to commit to development process. In this phase, feasibility study of the proposed system is also performed. The main three feasibilities are: technical feasibility, which involves questions such as whether the technology needed for the information system exists and whether the firm has enough experience using that technology. Economic feasibility, which involves questions such as whether the firm can afford to build the information system, whether its benefits should substantially exceed its costs, and whether the project has higher priority than other projects that might use the same resources. Organizational feasibility, which involves questions such as whether the information system has enough support to be implemented successfully, whether it brings as excessive amount of change, and whether the organization is changing too rapidly to absorb it. This also involves time feasibility to answer the question such as what is the total time required for the project and whether the organization is ready to devote that much time. If the information system appears to be feasible from all aspects, then this SDLC phase produces a functional specification and a project plan. In case the proposed system is not feasible to develop, it is rejected at this very step. The functional specification is the description of the alternative solution recommended by the analysis team. Once the recommendation is accepted by the organization's management, the project teams can begin to make plans to acquire or hire IT resources in terms of hardware, system software, and human resources to build or operate the system proposed. The overall requirements is finally documented as system requirement specification for further consulting both by users and developers during other phases of SDLC. After analysis phase is complete, design of the system begins. The design for an information system can be broken down into logical and physical design specifications. The fourth and fifth phases are devoted to design of the new and enhanced system. During design, IS technical team including system analysts convert the description of the recommended alternative solution into logical and then physical system specifications. Design of all aspects of the system, from input and output screens to reports, databases, and computer processors are mandatorily done. Design occurs in two phases, viz. Logical design and physical design. Logical design. Logical design lays out the components of the system and their relationship to each other as they would appear to users. It specifies what the system solution would do as opposed to how it is actually implemented physically. It describes inputs and outputs, processing functions to be performed, business procedures, data models, and controls. Controls specify standards for acceptable performance and methods for measuring actual performance in relation to these standards. Logical design is not tied to any specific hardware and system software platform. Theoretically, the system could be implemented on any hardware and system software. The idea is to make sure that the system functions as intended. Logical design concentrates on the business aspects of the system. Various standard charts and diagrams are prepared by the system analysts to illustrate data flows and processing steps for further use. Because the life cycle emphasizes formal specifications, many of the design and documentation tools such as data flow diagrams, structure charts, or system flow charts are used. Physical design. Physical design is the process of translating the abstract logical model into the specific technical design for the new system. It produces the actual specification for hardware, software, physical databases, input-output media, manual procedures, and specific controls. Physical design provides the specifications that transform the abstract logical design plan into a functioning system of people and machines. As said above, conversion from logical design to physical design takes place in this phase of SDLC. For example, diagrams are converted to map the origin, that is, starting point to other processing steps, flow, and processing of data in the system. This conversion is done into a structured system design that can then be broken down into smaller and smaller units known as modules for further conversion to instruction written in a programming language. Various parts of the system are then designed to perform the physical operations necessary to facilitate data capture, processing, and information output. During the physical design, the analyst team decides the programming language in which the computer instructions will be written, which database system and file structure will be used for the data, the platform that will be used, and the network environment under which the system will be run. These decisions finalize the hardware and software plans initiated at the end of the analysis phase. Now, proceedings can be made with respect to acquisition of any new technology not already present in the organization. The final product of the design phase is the physical system specification in a form ready to be turned over to programmers and other system builders for construction. The physical system specifications are turned over to programmers as the first part of the implementation phase.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code Mmpc 008, Information Systems for Managers. Course Coordinator, Professor Anurag Saxena, School of Management Studies, IGNOU. Voiceover by Renuka. Edited by Ruchi Sharma. Program assisted by Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.